everybody that's in attendance today and that may take a look at it in YouTube in the future. My name is Matt Petrie. I'm based here in the Dallas-Fort Worth area for Grafana Labs. If you've heard of Grafana or Prometheus in the past, you may have familiarity with who we are, what we do. We're a very large open source community, a very popular open source set of technologies, and a fairly small but fast-growing commercial company, Grafana Labs, behind that, with partnerships across other technology partners and cloud providers. And so I encourage you after this session to go to our website and check it out and learn a little bit more. And certainly we're available after this session today to answer questions. I'll just make one comment about our community activity. Community as an open source company is critically important to us. We are invested in working with Kubernetes groups and cloud groups and DevOps groups through Meetup and CNCF, really just to share information and share the things that other companies and other organizations are doing with Grafana and the related open source products. And so, you know, we are very interested in participating in these types of events and really just getting developers together, talking about the things that they're struggling with and maybe sharing information about what they're doing with Grafana or other related products. So please consider this kind of an open session. We'd love to come back sometime in the future and maybe do a follow-up, but we'll leave that to the organizers. But please do keep an eye on our events page as well, because we do these types of things with other groups and as a company, and we want to make sure that we share information on a regular basis to support the developer community. So with that, I'll leave it at that. You have a way to get in touch with me in the chat if you'd like to follow up afterwards. And I'm going to turn it over to Ed to introduce himself and kick off from there.
Real quick, say I'm really excited for y'all's talk. I think you're one of the best groups. I follow your project. I just wanted to say I'm just really excited. So it's good to see you all. And yeah, go ahead, Ed.
That's great. We didn't.
Thank you.
Yeah. Or yeah, we didn't even send Brian a T-shirt. So maybe we need to do that for the plug there. Thank you.
No problem. All right, let's do this, Ed. Take us away.
All right. Thank you. So I suspect everybody is here because they're interested in logs and hopefully to hear me talk about some things with logs, some problems with logs. I wrote this application earlier today to generate some sort of funny looking logs because, you know, this is the sort of world we live in, right? We have an unending amount of logs that we're trying to deal with, and that creates some interesting challenges for us. So my name is Ed. I'm an engineer and recently engineering manager at Grafana Labs. I work primarily on the Loki project as the tech lead for that project. I've been here just about 2 years. Prior to that, I have had kind of a varied career. I worked in, you know, the first part of my career mostly in embedded systems and kind of in C and in microcontrollers. I worked, you know, from that into some software systems, ended up at a telecom company for a while. And that was kind of my first exposure to like what the best of the, you know, 2000s era could build for software apps, and, you know, probably sort of what makes me inspired to help fix some of the logging problems that we've run into. And then, yeah, since it being at Grafana, I've been probably working on Loki, and I'm going to talk to you about that and a couple other things today. So this is what I kind of want to cover. So I want to give a little bit of background on, you know, the title of this talk, Logs Are for Humans, is to talk about kind of a growing problem within the logging industry, or you know, some challenges that we have as operators and developers versus, you know, the interests that we use our logs for outside of those purposes. So I want to talk about how we got here a little bit. I'm going to talk about Loki. I'm going to give an intro to, you know, what Loki is, how it works. Going to give a demo, and then at the end, I have some, you know, some pointers, some tips with my experience that will hopefully be useful to anybody, kind of regardless of what logging solutions that they use. So prior to kind of digging into the logging problem, I actually want to talk a little bit about metrics. And, you know, this poorly constructed, history of metrics, but there's sort of a reason for this. And if you look at the timeline here, in the sort of late 90s, metrics and monitoring, the only thing I could really find that kind of fits that space is this app called Big Brother, which was built for monitoring networking infrastructure. You get into the aughts and you start seeing Nagios. We've all, probably had some exposure to Nagios, Graphite, Cacti, Splunk. There's certainly others in there too, but this is where, I think you have a real big investment in companies into doing software development. And, this is where I think you also start to see, the building of monitoring tools, metrics tools, but it's not really until you get into the 2010s and even late 2010s that level of maturity really increases. And kind of what that means is, a lot of the applications that come out of the 2000 eras, and even recently, right, the primary tool for, introspecting their state and knowing what's going on has been logging. And, that's sort of what we're here to talk about. I just kind of Googled to see, like, what's the history of logging look like? And this was kind of an interesting tidbit, right? So syslog is sort of one of the probably early, sort of logging kind of, standards that people have come across back from the 80s. So syslog and logging been around a little while. And I think most people come across their first log as a developer in some format like this, a hello world. It's basically proving that your application works. That usually evolves into something like this, right? I'm communicating some state. I mean, this is sort of what my history feels like with logging. I start communicating out that something's working. A lot of applications that we work on tend to be machine to machine and don't have a UI. And even if they have a UI, you still find yourself looking at logs in order to figure out what the heck might be going on. And that creates this sort of world where, every developer creates logs that they see fit. One thing I think is kind of an interesting, observation is we don't typically find a lot of guidance on logging. You don't usually find a lot of instruction at university levels. You don't often find a lot of standards within companies about logging best practices. And that ends up, creating a scenario where logs sort of, fit what the developer's need was at the time. And, that can certainly create some challenges. And additionally, there's sort of other types of logging too, where, you find that this is an Apache common log format. It's an event log, right? So, every time a web page request is made, there's a log made. So there's more than just the log types that we create as developers. So you find that this is sort of, the evolution here has been, we have all this log data and, we want to be able to do more with it than just pull it up when there's a problem. And automation isn't strictly, what we're looking for here. It's just, I like this picture a lot. But it's more like, monitoring, alerting, metrics, right? I want to know, some business, business intelligence type stuff, right? I want to know, like, what successful percentage of orders there were, what types of orders people might have. I want to know security information, right? Like, there's a lot of useful information in logs, but, because of what we just talked about in that sort of free-form format, it's typically been hard to get that information into a usable state for machines to process. And so we're seeing that evolution now where logging is moving from, being valuable for a developer making an application work and perhaps being more valuable for machine processing to do analysis on. And using the the industry standard for how you determine the popularity, Google search trends, I went to look to see, what the occurrence of Json logging searches were. And you can see around, 2010 and later that you start seeing a lot of popularity increase in Json logging. And if you certainly have Googled Json logging yourself, you'll see blog after blog talking about how that's a good solution for, structuring your logs to make them more machine parsable, because, you find that this kind of log is hard to parse because, you build a parser that matches it, but if someone ever modifies that log line or wants to change or add a field, the parsers will break. And so that creates some challenges. And that's where Json was intended, I think, to help primarily solve a lot of these solutions, solve a lot of these problems. So, this is a same kind of access log and, a JSON representation. And, it's nice, right? Like, it gives you that, ability to extend it without, having to rewrite your parser. Most JSON, marshalers will handle different or adding, fields to them. There's certain things you wouldn't want to do, like change a field, but you can add that without causing too much trouble. However, I think that, we've started to suffer in terms of readability here, right? The JSON format isn't necessarily the easiest to parse. I think that sort of fixed format had some advantages. It doesn't tell you what each field is, but if you look at logs a lot, if your job is to look at logs, you would kind of get used to that field. And then I think, everybody's out there, well, you can pretty print it, right? You can pretty print a JSON log, but I think that creates a different problem where you've now sort of, exploded your vertical space requirement. And typically when you're viewing logs, your vertical space is more valuable to you because you might have hundreds or thousands of log lines you're looking at. So pretty printing does help, but it creates a different problem. So there's challenges here, and it can get worse, right? This is I pulled this today from one of our Google Stackdriver logs for, I think it's an audit log for a GCS bucket access, and there's a lot of information in here, right? Thanks Google, right? But I don't know what to do with that as a human. This log has very little value to me now. So I'm going to talk now about Loki and how it can hopefully help, us as humans work with our logs a little bit. But first, I want to dig into what Loki is. It's a horizontally scalable, highly available, Apache 2 licensed, multi-tenant native system, log aggregation system that was heavily inspired by the Prometheus project. And why was Loki created? I think this tweet does a pretty good service to some of the gripes that we've felt using log aggregation systems. I just want to use grep, right? That it's familiar to me. Why can't I just grep my logs? This is the other use case that I think Loki was built really to address. This is I want one tool to be able to do my incident response workflow. I want to get a page, pull up a dashboard, zoom in on one of those and manipulate those objects, quickly pivot to my logs, and then be able to then quickly pivot to, say, a trace in order to figure out what's going wrong with my app. And this is where Loki fits into the Grafana ecosystem here. So it's, as a Grafana product, it has, not surprisingly, first-class support for the Grafana UI. So that's sort of why Loki was made. The history of the project is interestingly coming up on about 3 years old, probably about 2.5 years of really active development. We did the 2.0 launch in October of last fall of 2020, and that was really nice in terms of some big improvements to the query language. So the project has seen quite a bit of development over the last few years. The kind of three areas I think Loki really excels, if I were to boil it down to three, is the query language, inspired by Prometheus. So there's a lot of Prometheus syntax within Loki's query language, specifically around turning your logs into metrics and graphing them, functions like rate, count over time, and you can even do some cool stuff now, quantiles and sums and averages of content in your logs. You can take numbers out of your logs and turn them into metrics. The other thing that is maybe, in my opinion, more valuable for Loki is that it does not have any opinions on the ingestion side. So we don't care about what format the log is when we ingest it. There's no requirement to sort of standardize it or manipulate it. It doesn't matter if it's JSON or a log format or some fixed format, or just Ed writing logs however he sees fit. The decision with Loki was to process that and improve processing that at query time. And this can really simplify the operational model in terms of how you deploy Loki and the requirements needed for, setting up the agents and shipping your logs. Excuse me. So the last part of this is that easy and affordable operations. This really comes down to the kind of structure of how Loki is built, the decisions that were made on how it works, the storage that it uses. So let's dig into that a little bit. The probably most important concept when you're new to Loki is that it does not do a full index of the log contents. So the only thing that gets indexed in Loki are some metadata associated with your logs called labels. And if you're familiar with Prometheus, it's the exact same concept as Prometheus labels, which is really why Loki got the nickname like Prometheus, but for logs. So we take the same label model, and for Loki, we really want labels to describe your sort of environmental config, your topology of where do your logs come from, the application, the cluster, environments, etc. And that small set of metadata is used to create the index. And then the log content itself is sort of separated out and stored separately as compressed objects. And the real reason that we do it this way is because we can really optimize for a small index. So you can take, in this example, I looked at one of our internal clusters, which is ingesting about, I looked at it over a sort of a fixed 10 terabyte amount of ingestion data, which was about 300,000 separate streams for that time period. And it generated 200 megabytes worth of index files. So if you're familiar with, a full text index solution, hopefully those numbers look impressive to you, because it's not uncommon, for a full reverse index to have a size that's similar to the size of your ingested data. And if you think about this, that means 200 megabytes of index can search through 10 terabytes of logs. And that 300,000 streams is actually probably more than it should be. Our internal ops clusters have some more aggressive labeling than they should. It's kind of a remnant of how we've built things over time, and sort of a little bit because we like to be mean to our ops clusters to make sure things are working well. But you could, if you wanted to, take a Raspberry Pi and use that to search this data. I'm not saying it's going to be super fast, but you can load the entire index into memory. The other part of how Loki works really well is the storage mechanism. So we built Loki as a database optimized for storage in an object store. So we have support for out of the box for S3 and GCS and the others that you see listed here. And those chunks we talk about get compressed and stored in an object store. And we actually store the index in there too. So the storage requirement is for an object store. And this is nice because it's affordable and it offloads some of the things about storage that are hard, right? Like you get extremely high durability and reliability out of every cloud offerings, object stores, and things that allow replication. And you get a high amount of query performance too. We can talk about that. Whoops, duplicate slide. So this part I just want to hit on once again, because I think there's kind of a sort of a mental model that needs to be built. So I think it's intuitive for many people. It was the same for myself, like working with relational databases. You tend to associate performance with having stuff in an index. And in Loki, it's kind of the opposite. And I will answer how that works. But for now, you're going to have to sort of kind of trust me here that the secret to success here is really being kind of stringent with your labels and really just sticking to things like, where logs come from. You don't want to index any of your log content. You just want to know where they come from. And so I thought I had another slide in between there. So this is the secret to how you make Loki fast, a system like Loki fast. The secret is in parallelization at query time. So what we do with Loki, we store all this stuff in this small index, and you can kind of think, I use this analogy some, I think it's a decent one, that the index is more like a table of contents. So, rather than the index at the end of the book that would tell you exactly what page a word is on, we have a table of contents, like the beginning of the book, that'll tell you what chapter, and that narrows down to say 100 pages. And then what we do with Loki is we split the query up probably to one querier per page, and then we just go out in parallel and say read all the pages. And that's how we can do needle in a haystack type queries still very quickly. We split a couple ways. We split on time, so we'll break the query up into time intervals from its start and end time, and then we'll also split on a sharding factor, which allows us to split that further so that we can just add as much parallelization as we want. And this is a nice sort of cost model optimization too. If you think about it, the cost for ingestion, the cost for storing your logs is kept very, very low. So keeping the index small and using an object store keeps your fixed costs of ingesting and storing those logs to be as low as possible. And then your query performance is actually some in your control, and the costs are somewhat in your control, right? So you can add queriers in parallel to increase query performance. And charge you some more IOPS and things like that from your cloud store, but that can be scaled up and down as you would like to. So there's sort of a nice benefit there, a knob that you can tune that's not essentially the case for a lot of systems. One thing that was added in 2.0 is a support for alerting. So Loki can generate alerts that will be sent to an off-the-shelf Prometheus alert manager. The syntax for configuring alerts is the same for configuring Prometheus alerts, except you can use the logql syntax to log type queries. The operational model for Loki is sort of as simple or as complicated as you need it to be. So the application compiles into a single binary. That single binary can just be run with a config file. This allows it to be run pretty easily on VMs or perhaps bare metal or something like that. We're at a Kubernetes meetup, so we also have and Loki was basically built for a cloud native environment, which is where we run it. So we use a tool called Tonka that was built at Grafana Labs as sort of a successor to Ksonnet. So it uses the same Jsonnet type configs to be able to build and deploy. And also we have Helm charts that support both the single binary, and thanks to a generous community member, we have the ability to do the microservices approach you see on this picture, which what that allows is taking that same binary, and there's a flag called target, and you can tell that binary to become a distributor or querier, and that is how you build Loki out to do this highly available, horizontally scalable part from that first sentence that I read there. And what's nice here is that you can separately scale the read and write paths. So as your write load increases, you can add distributors and ingesters. As you want to control your query load, you can add queries. The component that's not pictured here is called the query front end, which is responsible for the splitting and parallelization and coordination of that work. So the last little bit that I have about Loki in a slide format here is the agent support. So we have output plugins available for a number of projects. Promtail is the agent that we build, and the Grafana Cloud agent includes basically the code from Promtail. The Grafana Cloud agent is nice too, in a sense, because well, if you want to use Grafana Cloud, I would recommend that. But if you are running a system like Cortex or Thanos, and it allows for scraping Prometheus endpoints with sort of the bare minimum code required to do that and ship it to one of these sort of remote write endpoints for Prometheus. And it doesn't include the querying layer or any storage. So it's sort of an interesting model for using Prometheus without having to run Prometheus. I can answer questions on that at the end if anybody has any. But so I have a lot of slides here, but I instead want to try a demo. Everybody can see my nice sawtooth graph, and anybody kind of familiar with Java or .NET, or in this case, it's Golang. This is a graph of heap usage over time, and this looks a lot like a memory leak. And the reason I'm looking at this is because a couple weeks ago, I don't remember. Yeah, I got paged because of a restarting containers, went to take a look, and this is what I found. So I did this demo for a sales call earlier today, and I don't know, I guess ask me if it's a good idea to try to sell your product by talking about how it's kind of memory leak. But regardless, I think it's kind of a fun use case for showing how this tooling can work and sort of the process that I've built around using Loki. So this is a slowish leak, over the course of a few hours. And I think what I want to do to start with here is take just one reboot loop here. And first thing that I want to do, so this is a metrics. This is actually coming out of Cortex. And I just want to see the logs. So I changed data source. In this case, I had a very strict label. I'm telling it to look for a very specific pod, and now I'm looking at the logs for that pod. And as I scroll, I can see a whole lot of the same type of logs. So my Loki workflow always looks a lot like this, which is I want to start removing logs that are uninteresting to me. So these push, handler logs at the moment, I'm going to say are uninteresting to me. So I do a filter that says, not equal to handle. And now I get back a set of logs that does not include that. And I also can see that there's metrics endpoint here. And there's a ready endpoint. So I'm going to get rid of those too, because they're not terribly interesting to me. And error casting, that sounds interesting. And also there's a bunch of config dumps. So when these pods restart, we have a flag set that says dump the config to the log, which is sometimes useful, but I'm going to get rid of those too. So remove anything that says type equals config. So these types of filter expressions are very fast in Loki and a good way to sort of strip out, log lines you don't care about. Okay, so now I'm looking at a whole lot of these cast errors, which is compare and swap. So it's trying to reach out to console in this case to do some update, and that's not going terribly well. So I want to do a little bit more investigation on that error. In this case, I'm going to do this pipe equals or equals is what I usually say in my head, and that's going to say match only the lines that have casts in them. And I can see a whole bunch of those. This is kind of where we were before, but that's not as interesting to me as if I were to say look at a rate of those over time. And in this point, it's split by the restart values because the log file name changes for each restart. So that's not as important to me. So if I sum all of that, I can see, okay, there's some rate here. It's not terribly high. It's, less than 1 log line a second. But, the real question I have is, how do I know if this is related to what's happening? So I would want to say, look at a longer period of time. Normally, I would just extend that out with the last 2 days or 7 days, but this data is from days ago, 2 ago. So I'll just push it back a few days and, I only have a couple days for that particular pod because it was only scheduled. Let me, instead of looking at an individual pod, in this US Central 1 cluster we use a job label, which is a combination of namespace and container or the application distributor. So instead, let me look across all of them. Still have this wrapped with a summing operation. So, So it's going to give me just one result back. And this particular query is going to ask, so I have all those debug logs. So this is a fair amount of data. It's probably, a couple hundred gigabytes. We can look that up in a little bit. And interesting, right? Like I have a change here. So that's something that's perhaps curious. So let me do some more correlation. I'm going to go back to my metrics. Get these mem stats again.
Ed, sorry to interrupt. Is it possible? Is it possible to increase your browser font size? It's really difficult to see what you're doing. I'm sorry.
Yeah, sorry. 4K monitors. Is that better?
It is much better.
Yeah, I should have thought about that. Thank you
very much.
Thank you for interrupting. So I'm going to pivot back to, so basically I changed back to Cortex here. And I'm looking at the same metric, and now I'm looking at it for all distributors too. I'm dividing it by 1 million, so I get megabytes because scale we're talking about here. And I'm using the same time range now, which it's kind of squashed down because it's limited in window. And I would say, okay. And when I look at this, so now what I'm looking at is that same memory leak, right? But I'm also looking at it across the same time range. And unfortunately, that doesn't look like this is actually related to my problem. So the good news is I've got more information, right? But so, this particular increase in these cast errors started on, 111 in about 1906. And if I look at, a similar time frame, somewhere over here, actually probably right here because we restarted a bunch of stuff. I can clearly see though that memory leak was happening, long before that, right? So not related in this case, but interesting, right? So I've learned something. So what I want to do is add my list of suspects. And now I'm left with not all that many logs, 52. And all they are is a couple restarts, right? So good and bad news of this particular demo is that it's kind of fun to go through, but it actually didn't answer my question from the log. So in the logs, I don't actually know what happened here yet. So I'll talk a little bit more about what happened because I do know now. But before I do that, there's one more thing we can do here that's kind of interesting, which is I had originally excluded all of these handle logs, but they have some value in them that might be interesting. So they have this duration in them. So, maybe I can ask some questions about, if the performance of this is being affected. And now I'm going to start playing around with parsers, which is a log format or a log QLv2 edition. And this log line is in something called log FMT, which is a key value pair. So we have a parser for that. We have a parser for JSON, and we have a parser for regex. And if you can use the first two, if you don't have any choice, use regex because it's the slowest of them all, and also writing regex is the worst. But this is log format. And so what happens here, if I expand one of these log lines, these are the labels that we assigned with Promtail at ingestion. It's kind of the basic scrape config that we provide Promtail in our Kubernetes environments. And if I run this again and pipe it into log format, now I've taken all of these different key value pairs and made them labels too. And in doing so, do a lot more fun stuff. They show me only the log lines that took longer than 500 milliseconds. And interesting, right? There's definitely a few, but maybe a more fun is show me all of these. I want to say quantile over time. The 99th percentile quantile over 1 minute range. Aggregate that by pod, just so that because I'm creating all these extra labels by doing log format, I'm kind of squishing them back out here by oops, I skipped a step. Before Loki to know how to turn a value out of the log line into a metric, I have to use a function called unwrap. And I'll explain this. So I'm looking at the duration value, which is in Golang, you can have a sort of a united time. It'll show you milliseconds, seconds, or whatever. So we have a function here that will tell this parser to unwrap that as one of those time formats. It's just coincidentally named duration, and so is that value. And so now I'm going to pull back over this 3 or 4 day period here, which this particular app didn't have logs for all that long of a time, what the 99th percentile query time was. And interestingly, right, it's actually not bad. So, for that time period, most of the response times are in the single digit milliseconds, even though the memory is leaking. So interesting, but it was kind of not, answering my question. So I'll give you an answer to the question of what actually happened here. So the next step we took was to pull some profiles out of the process using Go's pprof tooling. And we discovered that there are 2 ways that the distributors can ingest logs from a client. One is using it's a snappy in compressed protobuf, and this is the sort of most common way. Or you can send a JSON object that fits our API format. And we had found that somebody was sending a JSON object that was particularly large, like 50 megabytes or something like that. And we used some pooling, some sync pooling within Go to create space for receiving these objects. And the sort of particular nature of how we were receiving these objects caused us to allocate space in that pool. But it was not able to return it very effectively. So we kind of continue to allocate space out of the pool And I didn't fix the bug, so Cyril's not here. You have to tell you, but what we found is that we weren't really processing the JSON very well for that particular size and not able to return that value to the pool, and effectively we're slowly leaking some memory over time. So maybe a bad example for solving a problem with logs, but kind of a fun one. I did want to quickly show sort of how we use some other features. So I'll show you the other side of this, where clusters. I'm going to look at some of the query logs for what I was just doing. I'm going to filter on a very specific log line because that contains metrics around the queries themselves. Format that. I'll do 5 seconds and see if I can catch. Might even try to find that query I sent. So this was that query that I sent that said, show me the sum rate of all of the distributors for that CAS error. It was 74 gigabytes of data, and we processed it at 6.2 gigabytes per second, which is not too bad. Depending on queries, our parallelization performance gets us from this range, which is fairly typical, up to as much as 30, 40 gigabytes per second. There is some ability for us to continue to just sort of add resources to make that faster. And in general, that performance is generally good enough. I mean, we are always continuing to sort of push that boundary and see how fast we can make things. But the other thing I wanted to talk about here is the human part of this. Let's tie this back into the talk a little bit, because there's an aspect of this, even though I think log format is generally pretty readable, there's some things we've added in here to improve this a little bit, which is a templating syntax, which is Go's templating syntax. If I can say, just show me the duration, this, create our own. And let's do throughput, because not. And then the last thing I want to do is trace ID, which we can do with this. So I can take that same log line and basically just rewrite it. And this is really nice for, and I'll show, I have a slide that demonstrates this a little bit better for JSON log lines, because you can take the content out of JSON and rewrite just values of it to be able to kind of simplify complicated logs. But one thing that's kind of neat here is with that trace ID, you can link to tempo. Oh, tempo, not going to do well for my query. If we can find another one. Tempo is the tracing backend that we Grafana just recently announced, and it has a very sort of similar approach to storing traces that you see with Thanos, Cortex, Loki, these databases that are optimized for object stores. So it's built to store everything in an object store and has a very sort of low overhead. And basically, the decision there was to say don't include a query layer and use tools like Grafana or Loki to be able to find. There's a query to be able to find your traces, and then it can be very fast at pulling back. So these are some examples of how you can kind of pivot between your metrics and logs. So I will show one slide out of this long list of slides that I saved you all from. So this was another example of log format, which is a little bit perhaps better in the sense that it shows you can include things like printf, and you can do fixed width spacing. And this is really nice. I find, for me at least, being able to horizontally align things when I'm scrolling them is a lot easier for my eye, specifically if I'm just kind of, looking for a problem that I don't quite know how to pin down. Another thing that I would comment on that I didn't have in a demo here is an example of a 99th percentile quantile where we're unwrapping something that's a high cardinality value like org ID. So, using your logs, you can now do histograms on things that were typically hard to do in metrics because of the cardinality of the value. Another example of something similar where you can do the same thing for an IP address. So like looking at load balancer logs, or rather our ingress nginx logs, to be able to say, aggregate that by a high cardinality value like remote address. So some nice capabilities that unlocks as well. So just a couple more things here. And this is the part where I want to just, share some of my opinions on, I think, things that anybody could probably do to improve their life around logging. Structure is a thing that you should definitely do if you can. I really like log format because I think it's a nice combination of human readable and still very machine parsable. It still has the capability of allowing you to add, without breaking anything you have parsing. And I think the nice part I'll mention a little more when we talk about JSON is that it sort of forces a flat structure. So JSON logging, this is meant as a joke because I know that JSON logging is extremely popular. But I would point out a few caveats that we run into is, Google's example of really big, complex objects. These are not easy to read. Pretty printing them doesn't really solve the problem because it just sort of vertically consumes your space. And then you end up needing an entire other query language to work within that, right? So you need JQ or JMES path. And we're actually probably going to incorporate JMES path into Loki's query language. So it's, it's sort of a necessary evil to work with these complex JSON objects, but all of that can be avoided if you just kind of put some effort into not getting too carried away in building really heavily nested objects. Try to keep your objects flat. These are logs for after all, like it's, I mean, they don't have to be. I do some weird stuff with Loki because I work on it and it's fun, but for production logging systems and users and people alike, it's just going to make life easier if you keep your objects sort of smaller and flatter. And log format kind of, because it doesn't really support nested objects per se. I mean, you can do some stuff, but helps, make that happen. I didn't talk about this when I give the demo that I had originally, or the first slide, but this is very important when working with logs. Is as a developer, when you're writing a log, never write a log statement, never print a log statement that doesn't include unique identifying information. So always include order ID, user ID, trace ID, something, or all of those things. And then, a tool like Loki can unlock your ability to aggregate on those fields. But just, looking at my sort of fun application here, right? So just trying to understand, which of these threads errored isn't possible if there's nothing uniquely identifying them. So, with all of these processing orders and error messages and things. So always include context. Every log statement you ever write includes some context. Log levels. I don't have a lot of great advice here. Generally, I would say, my opinion is that error level logs are something wrong with your system. It's something that your operators need to fix. Warning level logs are something that's wrong with the data your system is receiving. It's your users or customers, and it's useful to separate it so that you can help them solve their problems, but it's not something that you are actually responsible for. Info, debug, trace, I don't know. I mean, in some ways, they're kind of all the same. I think we all sort of struggle with what's the difference between an info log or debug log. I think that with Loki in particular, there's some other thoughts you can apply here, some different thinking. So we back up a little bit to that model of the key value pairs of a label set in a log line determine the stream. So every unique key value set defines a stream. So there's kind of a knob you can tune here where, our ingress controllers log 18 to 20 megabytes a second. It's pretty high volume. That's something like 70 gigs an hour. And even if you're highly parallelizing those queries, it's still sometimes tedious to search for many hours or many days. It's just, becomes terabytes of logs. So you could extract data from that log line, and we pretty much all of the agents have some format to do that. Incorporate that into a label. We do this with our ingress controllers. We split that stream using the content within the label or within the log line to split that stream a few ways. And so maybe instead of one stream for our ingress controllers, we might have 4 or 5 based on the downstream that they're supporting. So that allows us to kind of reduce the amount of labels or logs we have to query. So labels should always primarily just reflect your topology, where your logs are, but they can be useful for when you start getting into logs that are streams that are in the megabytes per second, to be able to split them apart a little bit. And then the last part that I have as far as advice is someone that does a lot of systems operations. As a developer, never write an error message that doesn't tell somebody what to do about it. And a couple of examples here. This is actually an error that I've received. I got a page because of I think this was Cortex, but can I allocate memory? Like, well, that sounds bad, right? And like, I don't know what that means, like, or what I should do about it. And in this particular case, actually, the node that this was running on ran out of memory. In the process of doing so, the node evicted pods and freed up memory. So Kubernetes sort of recovered this for us, and the system self-healed here. So adding to that log message, check memory and checkpoint process will automatically try would have saved me a lot of grief and time. I think this bottom, I sort of forget why I added this now. Just another example of an interesting log line I found. I don't even remember the app where cannot tear down log stream. Like, is that bad? It's a warning. Like, do I care? What should I do about it? So, always have an action. This is just kind of a fun one. Like, I've seen this before, and it can be actually pretty handy. If you something is never supposed to happen, it's okay to put that in the log message so that whoever encounters it, doesn't spend unnecessary time trying to understand it. So, out of my quick summary of helpful tips, structure your logs. JSON is totally fine. I think log format's a little nicer. Keep things simple and flat. Always include context. Errors really must include some instructions for the operators that are going to encounter them, and that log levels are kind of, I have opinions on error and warn. I not necessarily in a position that I would strongly defend that. It's just sort of a thing that I found useful. And I think everybody should give Loki a try. So thank you for hanging out. I didn't start my timer. I don't know what time it is. I feel like it's been a long time. So hopefully that wasn't too much. But yeah, I'm happy to take questions. You can find me in those various places. Grafana has a public Slack, and I'm Welch there, and Twitter and GitHub and anywhere else. This I've linked in here too was kind of a fun way to get started with Loki. If you're not familiar, was a project I made to be able to store your shell history in Loki. That's actually been kind of fun. Yes. Thank you.
Thank you very much. Thank you. Let me just stop the recording.